life easier. So they prefer you to stay home, but from the student point of view, the problem will be the postgraduate, blah, 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 blah. So the problem when you're going to ask your postgraduate work permit, they're going to be the problem in there. Okay. All right. I hope it's clear for everybody, right? I hope it's clear for everybody. If you have any questions further, please ask the school, not me, because I told you, I swear, I didn't even know this and I didn't want to know it, but it was an interesting meeting yesterday. We discussed a lot of things and I asked questions that was intriguing me about what is happening, right? So so since some few things was being clarified, so I'm just clarifying them with you. One more time, please, if you are online, go on ground. If you have to stay online for some reason that I don't know and they don't want to know, it's you, between you and the school, not me. But please contact the school, because if you stay online, you're gonna be at risk that you will not have your postgraduate work permit. Okay, Joban, please, for the attendance. Joban, do you hear me? Yeah.
Yes, Sanjay.
Yeah. So for the attendance, you take record of the people that they are with you on the classroom. So you tape on ground, right?
Sure.
If somebody is just in Zoom, make him present, but put online. So he's gonna be online, right?
Okay.
Well, at least they're gonna know the school. Here we go.
Right.
All right. So yeah, let's study now. God, I hate those things, but sometimes we don't have choice. Okay, so you remember, guys, last week we did a static route. We had a server, for example, S1. Remember, ask questions, right? If you are mixed up with something or whatever, just stop me and ask questions. And we had 4 switches or 3 switches or something like that. Yeah, 4 switches. We had 3 routers. We did the long one, the long scenario, the biggest one. And it was something like this. And here I had that Windows 10 that he was able to join the domain, and we configured static route everywhere, right? So we did it with the static routes. And we said that the static route worked with the logic that each router, for example, this was R1 and R2 and R3. So each router need to be configured with what he can see, what he can see. For example, I have this one going to be switch S1, the area S1 that it's 10, something, something, something. And this is S2, and this is the subnet mask, the network ID S3, sorry. And here I had S4. And this one was the S4. So for example, if I take R1 here, he already see S1, S2, so the static route that I need to configure for him is S3 and S4. So I need to go there and teach him how to go to S3 and S4. So those were the static route that I need to configure on R1. And on R2, we configured the static route for S1. So you see, because S2 and S3, they are connected to him, right? Like in this one, we didn't do for S1, S2 because they were connected to him here on the card. So Ethernet connection, and here we have Ethernet connection with S2, S3. So we are missing S4 and S1. We configure S1 and S4. And in R3 here, we also have a connection in Ethernet 1 for S3, S4, and we configured static for S1 and S2. All right. So we configured static for S1E and S2. I hope you remember that. And after we did the default gateway, of course, here. So the default gateway was the IP address S4R3 here, right? So it was S4R3, this address, the router R3, the IP S4, and this one also should have a default gateway as R1 S1. Everybody remember that, right? I don't know where is the, it's closed here. My Zoom also is weird today. When I share my screen, everything and everybody disappear on the other side. All right. So this is what we did, and this is what we configured. And after I give you a lab, and I deleted this route 3, I guess, in the lab, and I told you this one is connected directly to this area, so you have just 2 routers. Well, in that case, you don't need all these static things. You need just the S3 in this one, because he can see S1, S2, so you need just to program S3. And R2 need to be configured with S1 here. So this is the solution of the lab that I gave you, right? So since we removed that part here, you don't have all those other static for S3 and S4 anymore. S1 should be here. It's not S4, it's S3. Sorry, and here it's S1. So R1 can see S1 and S2 connected Ethernet, and he can see S3, and R2 he can see S3, S2, but he can see S1. Okay. All right. Now, what if we're gonna do a DHCP here? Let's say this is 10.0.0.0/8. This is 12.0.0.0/8. And this is whatever 13.0.0.0/24 for the zone S3. This is for the zone S1. And I will want to configure my client here, so Windows 10, dynamically with the default gateway and DNS and IP address from this server, the DHCP here. Okay, so what I have to do, which scope I have to create here? Come on, wake up, help me. I'm waiting for the answer here. Come on. Which scope I need to configure to get Windows 10 dynamic? S1, S2, S3, all of them. I don't know. Come on, anybody, come on. Hello. Okay, Toyesh, Kumar. So we need to configure an S3 scope, right? So I need to come to this DHCP and say that we're gonna have first address is 13.0.0.1, for example, and last address is 13.0.0.254, and the 003 for the router default gateway is gonna be 13.0.0.100. Let's say this one is the 100 here, right? So the default gateway of the client is gonna be 100 here, and the DNS for 006, if I want to join the domain, of course, here, it's gonna be 10.0.0.1. The address, let's say this one is the .1 here, so the IP that is here, okay? Okay, so I have my scope for S3. This is S3 scope, so I'm gonna configure it in the DHCP. Is it enough? So if I configure that thing, it's gonna work? You think? That was question, right? I'm waiting. I'm waiting. Wake up, guys. Wake up. Wake up. Wake up. So if I just configure the scoop in there and things gonna work and my client gonna have no. Okay, why? Why? Anybody can tell me why? Toya, she's saying no. Still can't work. Can you explain me why it will not work? Hello? I asked again why it can work. S1 machine cannot ping Windows 10. S1 machine. No, she can. She can. We already look, Davinder, we already configured our static routes, right? So I have the static route here, I have the static route here. Should ping. If I put the static address here, it should ping. So we have a routing over all the switches. Again, Toya, S1 machine cannot ping Windows 10. This is what Davinder said. It's wrong because of S1 can ping Windows 10. If I have anything static IP address here, I can ping S1. I already configured my static routes. So I can pass over the routers and ping. So S1 machine can ping Windows 10. Or otherwise, why did I configure my static routes here? There's more deeper logic about that. So it's true, it will not work. I will agree with that. But why? Who can give me the logic behind why it will not work? Come on, come on, come on. You know it. You know it, you know it. We studied this. You know it. We did study this time ago. Come on, is there just Davinder and Toyash in the classroom? Seriously. I need to put an additional IP of switch, which will act as a DHCP server in S1. Oh, no, I already have my DHCP in S1. So why I need all the things that gonna act as a DHCP in S1? I don't need something to act as a DHCP, Davinder, on S1 because I already have the DHCP in there. And this also your answer looked like a solution. I'm not looking for a solution, right? So please understand my question. Why it will not work? That's it. I'm not asking how we can make it work yet, right? I just want to understand what is the problem, why it will not work. Since this guy can ping this guy here and our static route are working, and if I configure the DHCP here with this scope, this one will not receive an IP. Why he will not receive it? I'm not looking for a solution yet. Come on, anybody, come on. You know it, you know it. We studied that. How does CP work? Remember. Think about it. How would DHCP work? What is the process of DHCP? You don't remember the process of DHCP? Nobody remember the process of DHCP? Request and reply. Good, Jaskaran. You are in the right direction. How request and reply? More detail. We studied more details. We didn't say request and reply when we studied the DHCP logic or configuration in block 1. Okay, we request IP from DHCP and it give us 1. Yeah. But how we request it, how we do that request? We even named it, etc. How we do that request? What was that request? One more time, just Karan is saying that we need to request an IP from DHCP and it work with request and reply. He's missing a lot of details. We studied this with more details, but at least he's in the right way. But how we request something from DHCP? ECMP, nope. Tarampreet, nope. Well tried, but not in ECMP request. Toyash say continuous packet for all the machines. You are so close to it. So close. Continuous. What is continuous packet for all the machines? What we call that? What we call that? Continuous packet for all the machines. Yeah, it has specific name that we studied. Continuous packet for all the machines. Interesting, but so close, but you're just missing the word now. Come on, guys. He gave you the answer. What continuous packet for all the machines? What we call that? What we call it? It's a router. So continuous packet for all the machines. We call that router, Ankush? Nope. But of course, the router is also part of the answer for the question that we are asking. I don't know if it's what you mean. So here we have the answer, but it's still completely destroyed by the way that you say it. Toya said continuous packet for all the machine, and Ankush said the router. Right? So if we see it clearly and put it in the right order, we're gonna have the answer. Why it's not working? One more time. Toya is saying continuous packet for all the machine, and Ankush is saying router. It doesn't remind you anything. So why you are learning? You learn to forget things. Important things like this, it's important thing. Not just a detail. Come on. You can do it. Come on. I know you know it. Because once if I'm gonna give you the answer, you're gonna say, oh, okay, yes. I'm sure that this is what you're gonna feel. So you knew it. One more time. The correct wrong answer. Continuous packet for all the machine, as Toy said. So this have a name. And Ankush is giving a hint here, saying router. Continuous packet for all the machine, router. What is this? Doesn't remind you anything? Come on, somebody. Okay, shame on you, all of you. But the ones that at least they tried, right? Those ones were good. We are friends. Even if it was wrong. Good, Muhammad Said. Good. Wow. He saved your honor for all at the last second. Muhammad Saud said something interesting. He said broadcast packets. Hey, Toyesh, isn't it a broadcast? Continuous packet for all the machines? We call this broadcast or not? Right? So the DHCP work in four phases, right? Of the port 67 and 68, and one is for receiving request, the other one is for answering. And this is the client here. And the client gonna send what is the first request? What we call it, this request? I just said it. Mohammed Saud just said it. What we call this request? The first one here. Discover. Okay, so good. This is a DHCP discover, right? So we discover if there is a DHCP in there first. And since we are discovering, we need to send to all the addresses of our network to see if there is a machine there that's gonna answer to this discover packet. So this is a broadcast. And after he gonna answer with an offer. Right. That offer will be a unicast because now when we know the IP of the client, he will just answer to the client, not to everybody. And after he will request it, right? So he will request it with a unicast because in the offer, we know now what is the IP address of the DHCP. And we're going to have an acknowledgement ACK here, packet. We acknowledge that, okay, we give you that lease and you're going to keep that IP address, etc., etc. Okay. But this first one here is a special one, right? The discover request is a broadcast. Okay, so this is the half of the answer. Now, Ankush said something interesting. He said, router, what's wrong now? Come on. Now, if you don't give me the answer, I will lose faith on you guys. Come on. It's in front of you why it can't work. So if we mix these two, we know why Windows 10 will not be able to take an IP address from a DHCP. Come on, who is the good guy here in the classroom? Come on, who's the master? So the process of DHCP is sending a discovery request as a broadcast. And Ankush said routers. Routers. He didn't say routers, by the way. He said router, but I'm helping you. I'm saying routers. The client need to acknowledge? No, it's not the client that need to acknowledge, Toyesh. It's the server that acknowledge. at the end. It's the last one, but there's no problem with this one. This one is unicast. If the discover worked in the offer and the client accept the offer and he will request it, the server will acknowledge at the end. It's kind of signing the contract at the end, right? So I will give you a copy of the contract and you're going to tell me if you accept it here. So you're going to request it. Yes, I need that. And I'm going to acknowledge. I will send you another copy of the contract, but signed, right? So I will, like, the confirmation of that. But the problem is not in the acknowledgement at all. Come on, people. It's in front of you. The answer is in front of you. We need to send the broadcast discovery to the server DHCP to get an offer and requesting that offer officially here and having acknowledgement. And Ankush said a very interesting word here. He said routers. So what is non-normal here? What is not compatible? What is wrong? Come on. Hey, we don't have all the day. It's already 9:10 here. Hello, dead people. Come on. Come on, wake up, guys. Wake up. Try it. Try it. Routers, it's in front of you. The answer is in the screen. What is between these two things? What we know about these two things? DHCP is dynamic, but we have static route. 524, I don't know who you are, but not really. DHCP, we have static route, and yeah, what is the problem with it? What is the technical problem? What do you mean by DHCP is dynamic, but we have a static route? DHCP is not dynamic. The IP that it's configured every time, but the packet are the packets. Now we are trying to know why this DHCP will not be able to give an IP to this guy. Doesn't make sense, static and dynamic route, or the DHCP is packets that they're gonna go and give an IP to this guy, and this guy will send back the, this is how it should work, right? The same process, but over the routers. Over the routers. I'm giving you here the answer. It's done. Come on, guys. It's done. It's here. What is routers don't allow broadcast? Thank you, Tarampreet. Finally. You didn't say it. Tell I give you the food. Tell your mouth and right. Of course, what is about routers and broadcast? Remember when we studied collision domain and broadcast domain, and we said that the routers are the enemy of the broadcast. They stop the broadcast. There is never ever in the universe, even if you change a planet or you go to your other dimension, the routers never ever broadcast. The routers stop the broadcast. Right, this is how the broadcast domains are splitted. Remember, collision domains and broadcast domains. Okay, when we have a router and we have a broadcast domain in the side and another broadcast domain in the side, the router is gonna break that broadcast. This one will not be able to broadcast over the router, and this one will not be able to broadcast over the router. And we studied this with collision domains and the broadcast domain. And now everything is clear. So the DHCP with this configuration, he will be able to ping, he will be able to whatever, but he will never receive this request here that the client will send. It will be like a bottle in the ocean, right? So bottle in water or whatever. So the message will never be received by the DHCP first, because this guy, when he's gonna broadcast this discovery to see if there is a DHCP, if there is a DHCP machine here connected to the S3 switch, all good. So he will send the broadcast, this guy will receive the broadcast, he will answer to him with an offer, he will request it and the acknowledgement, and it's done. The client is configured. But the problem here, when the client will broadcast over this router R2, the broadcast will stop here. The discovery request will never go till the machine, right? So this is the problem we have with the DHCP over any type of routing. So if there is a router in between, the DHCP will never be able to jump and distribute addresses in the other side. To solve this problem, we have a special protocol that was being created and invented that we can configure. It's called the DHCP relay agent. DHCP relay agent, or EP helper in Cisco. We're going to configure it in module 4, this one, right? We're going to configure an EP helper in Cisco. In Microsoft, we call it the relay agent, or in general, we just call it DHCP relay, right? So if I come to this card here, see the card that I have, that I'm having here, and I will configure that relay, and this router will be able to ask the DHCP in when he receives the broadcast. He will be able to play as a connection point, right? And the DHCP will be able to give him the information about the scope here, and he gonna do the rest, right? So when we have the relay agent configured here, the Windows 10 will be able to talk to the DHCP over this relay agent that we configure in this card. Is it clear? And this is what we're going to do. Okay. So one more time. The client here will never be able to get information of this scoop because the DHCP server will never get the request discovered from this guy because the router is going to block it, right? So he's going to stop the broadcast here. Okay, the first router, it will not even pass the first router, right? So it will be stopped here. But in this case, we have a solution that we can configure. It's another protocol that's called an EP helper or relay agent that we can configure in this card here. And once it's configured, this card here can play a connection point between the DHCP and any client here, right? So anytime this card will receive the broadcast, the relay agent protocol will play the rest of the role. So he will go to the server, he will fetch those information of the scope, and he will bring them back here, and he will negotiate the configuration with the client. Is it clear for everyone? Clear? Any question? We're good? Okay, so please, if you go to Moodle, let's start talking about the document that I've given you in there of the DHCP. Just give me a moment. I don't know if I already shared it or not. Nope. Okay. So turn on. So I give you 2 documents today on the things related with the DHCP. This one is the theory part and DHCP relay agent, because we're going to do both of them. So if you go to Moodle, you're going to find DHCP PDF, and you're going to find the document word named DHCP relay agent. So the DHCP relay agent is nothing in there but the configuration steps of the, not this one, the configuration steps of the DHCP. Here is it. Okay, here you're gonna find the configuration steps of the DHCP, and we're gonna do it together, right? So this is just for you after to remember or whatever. So this is the notes, and we're gonna talk about the PDF. Can we make S2 and S3 as bridges in order to? What do you mean by bridges? What do you mean by bridges, Davinda? Router acting as bridge. What? Yeah, but this can have a lot of significations as bridge. Bridge can be a link. Bridge can be a bridge. We have a device called the bridge, right? So this is why I'm asking you, what do you mean by bridge? We are making that as bridge. If you are talking just about the concept, this is it. In router 2, S3, this is the bridge between. We call it really agent. All right, but if you are talking about bridges instead of the routers here, if you are talking about the bridges, the devices bridges, yeah, we can do that. The bridges doesn't stop the broadcast, but it's not solution. It's same thing as you are making hubs or because the bridge work just on layer 2. Okay, and it's kind of you are putting switches here. It's the same thing if you're gonna put bridge, right? But the concept is we have routers, we don't have bridges devices. But if you meant bridge by the idea of bridging something to something, like a bridge to link two things, yeah, we are doing it's the logic of bridging here, the DHCP between this and this. But if you're talking about the device, no, it's not you can bridge everything in your company. What if you want to use routers, right? Yeah, but those are routers. We are configuring them with routers. Imagine you have REAP here, you have whatever EGRP or SPF or something like that. They are not bridges, they are routers. Routers, complete layer 3 that they're gonna block broadcast. And you have several ones, right? So there's no other solution by the bridge, the device, like the hub, right? Okay. But if we're gonna put hubs here or even switches, it's done. It's okay because they can see each other and they don't block it. But we don't have the same routing here, right? Because the bridge here, there is no routing in the bridge. The bridge we have just IP forwarding, okay? But we don't route over bridges. We just configure IP forwarding. We forward packets over the ports. Routers are much more than that. Okay, there's different people sometimes are confused between routing and port forwarding. Port forwarding is other thing, and routing is much more than that. Port forwarding is just we receive packets from one port number, and it's configured to send it to another port output. Okay, the routers they do not bridge, they work with the port forwarding, but they route the information also. Okay, they use routing protocols and they find what is the best path from one point to one point, for example, right? So they use routing protocol to find what is the best way to go from one point to one point. Routers work with metrics. Bridges, they don't have metrics. Okay, so this is the difference between port forwarding, just when you have a port forwarding configuration, but routers, the port forwarding is a little portion of the whole thing that they do. Okay, they have the port forwarding inside in order to use a metric to route the information from one source to one destination. Because it's two complete things. Okay, got it? So the concept here is having routers, so we can route. We're having routers here, okay? So in these routers, when we have routers, the broadcast will never pass over them. So this is the bridge. This is the link, the relay, right? The link that we're going to create between the DHCP scoop here. So this card will be able to go here and fetch the information of the scoop, and it like look like it's going to play the role of the DHCP. This card going to play the role of the DHCP here, but this card doesn't have the configuration of the DHCP. So it need to go to the real DHCP. We need to point it to the DHCP. So it's going to fetch the information of scoop and bring them back and negotiate on behalf of this server. Okay. All right. So please download the PDF, and you have also DHCP agent. It's a Word document. You have all the steps of the configuration, and we're going to configure it together, right? We're going to do the configuration of DHCP agent. But let's cover just a little bit here, the first part about the DHCP. It's in a review, just a little review. So the dynamic host configuration protocol, that is the DHCP server role. It's a role, right? So when we configure, we already know that. We did it many times. So it's a role that we add in the server. We don't have that as the feature in the client, right? I had an interesting question in another classroom that nobody asked me that before ever. What is the difference between a role and the feature, right? So the role is something that it's just for the server in general. So we put the role in there. But when something is considered also, a role can be a feature or can have features inside. Okay, but the feature is never a role. Why? Because of those features that we can add, even the role that have features can be configured in the client versions. Okay, but a role in itself, just a role, it will not be in the client. Okay, like the IaaS can exist in both, and we have the IaaS role, but the web server is a feature inside the IaaS role. So we can go to the client and just configure that role. But if you see the DHCP, it's a role. It's a DHCP role. A DNS is a role, right? It doesn't exist in the client versions at all, right? So you to configure your network client TCP IP more easily by automatically assigning them an Internet Protocol IP version 4 or Internet Protocol IP version 6 also, right? It's configured in port 67, however, server answer with the port 68. We'll just talk about it. So what is the responsibility of that DHCP? It provides IP addresses automatically, of course. This is the first thing, right? It ensures correct IP configuration. Of course, DHCP will not do mistakes like human being. Imagine if I'm configuring manually 100 computer, I can do mistakes. Okay, I can repeat addresses. I can do typo, for example, in the subnet mask something. But DHCP will never do that because it's just a robot and he will increment numbers and it's done. And when something is already assigned, he will never be able to assign it again because it's just removed from the available list of the IPs that he can assign after. Okay, it supports devices reconfiguration. So when a lease drop, we don't need to go and reconfigure the DHCP again or do something. It's automatically renewed, right? So the renew after the lease, it's done automatically. So the reconfiguration also, it's supported in the DHCP. It enables efficient use of available addresses, address pool. We can play with those range of addresses, like for example the subnets, or even if it's not subnet, so we can have multiple scopes and we can have better organization and we can choose our range. So officially we need 30 addresses available. Yeah, we can configure a scope just for these 30 addresses and we can exclude the others, right? So can manage this availability of the IPs much more efficiently. It centralized the IP configuration. Of course, the configuration, it's in one machine. It's centralized in the database of the DHCP because the DHCP is just a is just the socket that is programmed in some port numbers, and the requests all are redirected to a database, the database of the scopes and the scope options and all this information in there. So everything can be centralized in one place. The DHCP client broadcast. Here you go. We're just talking about it. He broadcast what? He broadcast a packet named DHCP Discover. All right, so the DHCP Discover is the broadcasted first packet here. Okay, discovered, called DHCP Discover. All right, so it's send it first to everyone because the client here, he don't know who's the DHCP. He don't have his IP address. If he have his IP address, like after the renew, he don't broadcast, right? The renew happened just from here, request, acknowledgement, and that's it, or request, offer, acknowledgement, something like that. Okay, so we don't have all this process of the discover from the beginning. Okay, and I always give you the example when we studied this as the lease of your apartment, for example, right? So the first time you're going to broadcast your request of searching, you will go to Kijiji and you will write, for example, an announcement in there asking for whatever criteria you need, right? I need and 3.5, this is the range of the price that I need, whatever, accepting dogs or not, something like that. All right, but well, you are broadcasting that on the internet, and if any other landlord, so he's going to be the DHCP, you're going to find your announcement interesting, he will contact you, right? So he will give you what? He will give you an offer. He will say, yeah, okay, I have this apartment, you can come and visit it and blah, blah. So you're going to go and visit it and whatever, and after you're going to request it, you're going to say, yeah, okay, I'm going to take it, right? And he's going to give you the lease and you're going to sign it and he will sign it, right? So this is the acknowledgement at the end. But 1 year pass, so let's say that your lease is 1 year renewal, 1 year pass, you don't broadcast anymore. You don't go to Kijiji to ask your landlord again over Kijiji. Right? You already know who's this guy, so you will just tell him, okay, I'm going to take another next year. And you will sign the lease. That's it. So you will not ask everybody in the planet for the apartment that you already have, right? So it's just a renewal. Okay. So it's the same thing with the DHCP here, right? But the first time we need to discover, because I didn't met my landlord yet, I don't know who have an apartment to offer to me. So I'm just asking that request, sorry, to everybody. And the routers block this thing. So this is why S1 wasn't able to answer. Yeah, here we go. I have witnesses. Just Karan. It's just going to say, I remember this landlord example from, yeah, it's always good when we can give examples because they simplify the memorization, okay, of the concepts. All right. So this is it. This is the problem with our routers here, that they were blocked here because that request we never pass over. Let's say here you need to have internet to to put that announcement of landlord in Kijiji. If you don't have internet, you will not be able to broadcast, right? So this is a problem. This router will stop that thing, right? So we will not have internet. Tell you're gonna pay a contract with your ESP or something. Let's call that the relay agent. So this is Videotron here. So they give you internet, so you will be able to use the internet to do that broadcast. Something like that. Yeah. So a DHCP server respond with a DHCP offer. Now he gives him an offer packet that contain a suggested IP configuration. Okay, so he will suggest to him, okay, I have this to give you this IP. This is 13.0.0.4 with this subnet mask. This is how I'm configured. This is the IP available that I'm having for you. So if you accept it, let me know. So the client will save the offer and broadcast a DHCP request for the first time, but after for the renewal, it's gonna become a unicast. So packets are, sorry. Yeah. So packets are packets that contain a server identifier. All right. The server that was identified use a DHCP acknowledgement saying that, okay, now we acknowledge that you have that address. So the message to the client to signify that the configuration is live, it's on, you have that, and that IP address is now leased by the client. So, and after he will remove it from the available IP addresses in the database. So he will put it on the side that this IP address is already assigned to a computer, and that we never offer it again to anybody till it's gonna be free again, right? So this is why he will not do this errors like human being. Scopes. So a DHCP scope is a fundamental component of a DHCP architecture. A scope contains a pool of addresses, IPv4, IPv6 addresses, and supplemental configuration options. Those are scope options that we can add, for example, a default gateway, a Win server, a DNS server, etc. So such a default gateway, a domain name, DNS, a suffix name, server, and also exclusions. We can exclude the addresses that we don't want them to be repeated, or we can reserve some addresses for static configuration, further static configuration, etc., etc. That we exclude from distribution from the designated scope. A DHCP server can have one or more than one scope. We can have several scopes. Okay, we can have several scopes. Like for example, here, I can do this, right? What if in this switch, see, so this one is 12, right? This one is 12. But what if in this switch, I will have another client here, Windows 10, that I want him to be configured from the DHCP dynamically, right? So I have one client in S3 and I have another one in S2, but you see that I have a router here, same thing. So I will need to create another scope here, second one, that will be 12.0.0.1 till 12.0.0.254, something like that, with subnet mask and default gateway and DNS and whatever. So this scope is for S2, right? So this scope is for the zone S2. So I will configure it here. And after that, I will need to configure a relay agent in this card, right? So the broadcast will be forwarded to the DHCP, and the DHCP will answer back here to the client. Okay, it's the same thing. If I have two computers, I can have several scopes, multiple ones. The more zones I can distribute for a lot of zones. We're gonna see it on Packet Tracer when we're gonna study that on the module 4. I will give you some examples like this. Where is my packets? It's just to have an idea about what I'm talking. It's not just virtual machines. It can be a lot of routers and a lot of zones and a lot of scopes. And each zone will be configured by a specific scope, like this one, for example. No, not this one, I guess. Right, but this one, for example, you see. So you see that each colored zone here is a subnet, a different subnet, and those are all routers. You see all routers here and here, and this is my server that have 1, 2, 3, 4, 5, 6. So you're gonna have 6 scoops, and each card here will have the EP helper or relay agent that is connected to the server, and it will play the role to distribute and answer the clients here machines for it. So the concept is not just this is a very, very basic example that we are having here in virtual machines. Okay, but the concept can be much more bigger, right, and wider. But this is the same logic. It's each zone, each separated zone by router. So the broadcast zone, each broadcast zone need to have its own relay agent. So as you can see, this is a broadcast zone. So this guy gonna stop broadcast here. So it need to have its own relay agent. This is another broadcast area between these two routers. So the broadcast is stopped here and it's stopped here. So I can configure my relay agent here or here, right? For S2 here, I can configure my relay agent in this one, because you see that the client can see this card, right? So I can configure it here or here. It's the same thing. You know, work same way. Okay. So such as a default gateway, domain, blah, 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 exclude from the designated scope. A DHCP server can have one or more than one scope. We can have several scopes. Super scopes. What is a super scope? A super scope is when we gonna kind of, it's a way of merging different scopes that they belong to the same biggest network. For example, and there is one scenario where we use them, so they are sufficient in there. Imagine that I have a 10.0.1.0. So this is the network ID /24 here. And 10.0.2.0/24, right? So those are kind of subnets in the 10.0.0.0, okay, /8, or something like that. Okay, but what if physically now, right? It doesn't make sense if we do it in virtual machine. We can configure it, but it doesn't really have a meaning. But what if in real life we have routers? They are connected physically, right? And we're gonna have some servers here, DHCP. I can have even another DHCP server here, and maybe some clients, etc., etc. And here also I will have another switch with a client. All right. And the problem here, or whatever, let's say here. Okay, I made it bigger for nothing. We don't need those things, right? One gonna be this is another switch, right, where I have another client and even another client here, and maybe even another client here, right? So this is another computer, and this is another client. This is another client, and this is another client here, right? So those are machines. And let's say it's outside, or even the DHCP can be inside. Okay, let's simplify stuff, not more complicated. What if this is a physical topology, right? So a router here in this switch, and in this switch I have a server, DHCP. The problem here that's gonna happen is, what if I'm gonna use VLAN inside, right? So let's say the green things, they will be one network, and the red one, they be another virtual LAN. Okay, so they are multiple, or I can have even 3, 4, 5, more than 2 networks, different ones, that they are exactly in the same physical one. I will have a problem here. Why? Because of this guy and this guy, they are completely in 2 different sides, right? Two different things, since they are in the physical. But as you can see, there's no router in between. The router gonna just push them to outside here. They are all inside. So this become one broadcast domain. All right, so it's so confusing having 2 different networks in the same network, 2 different, but they will be in the same broadcast domain. So we can have a civil confusion here. This guy can take this guy from the red ones, because the DHCP will not make a difference. When you save a broadcast, it's the same broadcast domain for him, right? So how are we gonna make the difference between these two? So we can build super scoops and have these 2 inside, so the DHCP will make a difference between these 2 that they are completely different, right? So somehow here, when the broadcast happen inside the super scope, we will know that this is one of the VLAN 1, the other is for VLAN 2. So those super scopes are made for logical networks inside multiple logical networks inside the physical network. We can have one super scope and inside several subnets inside, just to play the role and make the differences. Because like here, we don't have that problem, you see. So this is a broadcast domain, this is a broadcast domain, and the scopes are completely different. It's okay. But what if we have different scopes for different computers, but all working in the same broadcast domain? Okay, this is going to be a problem. In that case, we just configure them as a super scope, and everything will be configured correctly. Multicast scope, we can configure from DHCP a multicast scope. The multicast range is from 224.0.0.1 till 239.255.255.255, and this is just in case the one of the client need to use a multicast address for the others. Okay, so they can borrow an address for the multicast in case of multicast communication, like for example streaming something, or having a centralized VoIP communication over one machine, so the others can all reach that address of multicast, a specific one that we need to configure in a specific computer, and link a specific protocol to that machine, to that address specifically of multicast. So we can have multicast scopes also, so also known as multicast address dynamic client application protocol. So this is the protocol of the multicast configured by MID-CIP or MADCAP. They support apps that use multicast transmission to communication. So for example, if I have any computer that need an application inside to be able to communicate with multicast addresses, so I can allow that application here. I have, for example, whatever streaming application here that need a multicast address, so the others can reach that multicast address to get served by the service of that application, whatever application, right? Streaming is just an example. So if any application is programmed to take an address of multicast to be able to multicast to the others, I can configure scope here in my DHCP for some range for my computers so they can take multicast addresses. We have scope options. We already dealt with those things, right? Scope options, this is some examples. This is the most used ones, of course. Router here, DNS 006 and 015. We can have a lot of other things like WinServer and Pixie Boot that we can configure. NetBIOS, name for the WinServer, etc., etc. But this is one of the most used ones here in this table. WinServer here, the Pixie Boot here for all booting stuff, distant booting stuff, and the router DNS things here. Okay, so let's let those things here aside, and we're gonna continue with this part after configuring our machines. So I will turn on my machines that we worked last time. We'll try to configure 2 routers, and we will try the DHCP relay agent. And you're gonna see that it's pretty easy, right? If you understand the logic behind it, it's the most important part. You just need to know how to configure it after. It's pretty easy. The configuration part is very easy, not complicated at all. Okay, so what I have here, okay, I'm gonna need my primary domain controller. This is DC2 inside this one. I have router 1, router 2. I don't need router 3. I'm gonna need a client, by the way. Some client somewhere. Okay. Yeah, these merges, so just cancel the merges. Yeah, this PDC, the one that he didn't stop crashing, right? So we're gonna be patient today also, right? Because there's 4 chances that you're gonna crash. And we will restart it each time. I don't have choice. Please, if you have any question about what we're talking about right now, tell now from this morning. Feel free to ask your questions. One more time, if you have questions, please feel free to ask your questions. I will refresh this one. Okay, so let's log in here. 31. And I don't know what is the IPs here. We're gonna check them together and we will try to make our template back with the IP addresses so we'll know what we are configuring. Okay, so I can see that router 1 have Montreal, have Tokyo here. Yeah, I remember a little bit that. And we have Ryu and Tokyo. Okay, so Tokyo is between here. It's the 10. So this one should be S2. And this is R2. So this one is S3 here, Ryu. And Montreal should be in this one in PDC. Okay, so it looked like something. Oh, I remember. It looked like something like this. Okay, so we had the server PDC that have a domain here. I don't remember the domain. We're gonna see it together now when he boot. And we had a DHCP, I guess, also. I told you install DHCP and let it for next time. So he's connected to a switch Montreal. Okay, and after I have R1, and R1 is connected to a switch Tokyo. And R2 is connected to a switch that's called Rio. And last time we had another router and we had London in the other side, I guess, if I remember, but we will not do 3, right? I don't want to turn on 7 computers. So just those ones are much more than enough to understand and to be able to practice. So I have Windows 10 on Rio. So I will change the Windows 10 here to Rio, of course. Setting. What? So I'll be able to take an address from you. Was origin X administrator. Okay, origin, the domain was origin X square T1. And this is my R1. So I have here 172. Here I have 172. 24, right? Was it 20? Not this one. Where is it? Yeah, 24, 100, 100. So the server, I'm pretty sure that was 1. Right, so here I have 24, 100, 0 slash, I don't know if I took slash 24 or slash 16. We need to verify that. And my R1, I guess, oh, I thought it turned off because, you know, my computers can just crash like the, okay, so it's /24. I took /24, and the other one is 10.0.0/20/8. Okay. So this is /24, and here it's 10.0.0.0/8. And Rio, I have no idea. What was that? We need to see it on R2. It's 40 something, but I don't know if it's /8/whatever IP config. Oh yeah, so it's /8, 40/8. Okay, so here I can type 40.0.0.0/8. All right, good. So since my client will connect from Rio, the first scoop here, so I'm gonna have a scoop named Rio that will have 40.0.0.1 till 40.0.0.254. For example, I can go even higher here if I want. Maybe some exclusions, so we're gonna exclude the 1 until 10, so we'll start from 10 something. And the default gateway here will be 40.0.0. I'm pretty sure that it's 100, the address of Rio server here, but we need to confirm it. Here you go, see R2 100. So the address should be 100 here. So this one is 40.100. This address here. So this default gateway will be 003. .003 will be 40.0.0.100. And the DNS will be 172.24.006 will be 172.24.100.1, but we need to check it, right? Just to verify. Maybe I put it 10 in there. I don't remember. So we will be sure about it. It should be 1. I know how I work usually, but just in case. So should we be Montreal? Here you go. We verify that it's in Montreal because I didn't tape it here. Okay, it's Montreal, right? And we have the address 1. Okay, cool. Cool. And we had our static routes all configured, but we don't need all of them now because I'm working just in 2 routers, not the whole routing protocols, static protocols that we have. So as you can see, this guy here, he don't need now the older static route. All he need is to see, so we are on R2. We need just this one. There's no 30. London was 30. There's no 30 anymore, so I can delete it. And R1, he need just the 40. He don't need 30 also. Go. Yeah, he don't need 30. 30 doesn't exist anymore. All he need is the 40 R1. There you go, guys. See R1 and R2. So R1 need to be configured as a static route, static to 40, and R2 needs static. So this one to 40 Rio, and this one needs static to 172.24 Montreal. And this is exactly what I'm having here, right? So see R2, he can go to nope, I'm doing a mistake here, I guess. R2 doesn't need Tokyo. Well, I'm gonna do it again. It's gonna be a review. So R1, I'm on R1. Oh gosh, it was correct. I read R2 here in the cell configuration and skip this thing here. Okay, so I was in R1, it was correct. New static route. So the interface of R1, he gonna use Tokyo to go to Rio, and the destination is 40.0.0.0, and the subnet mask is 255.0.0.0, and I need to know what is the IP address in the Oh gosh, I deleted it for nothing. So it's gonna be the address of R2 in Tokyo, 10,00200. So this is the gate, right? 10,00200. All right, I just put it back. Okay, now with this configuration, if I configure with the right, oh, he already joined the domain, but we're gonna log on locally, administrator first, and QWERTY1. And I will change the IP addresses just to check that I can ping first and my routing is good, right? And after we're gonna take a break. So I'm gonna ping, see the ping that it worked. We're gonna take a break, and after the break, we're gonna come and configure our DHCP to be able to distribute that scoop over Tokyo to the other side, Rio. And after I will even do another scoop in Tokyo here, and move the switch. So I will take my client and move the switch to Tokyo, and you will see that when I move it, this guy gonna change an address here, and when I put it to Rio, he's gonna take an address here, right? So it's gonna be cool if he log on, of course. I'm gonna give him time. Take your time. Look like it's glitched here. So I'm gonna refresh it. Oh, not you. Again. You see he was logged in, but he didn't display anything. Still have problem with the administrator. Gosh. Well, I'm gonna give it time, right? I don't have a choice. Otherwise, I will try another client because man, I don't know what is wrong with this one. So let's take a break. It's 10. Let's take a break. Oh, here you go. It's come. Okay, let's change the IP address here and try to ping the. Remember, now I have the London. I'm gonna have 30,001 here, but I don't have that 30 anymore. Okay, I want to configure this thing on 40 something, right? 40, so CMD, and you're gonna find 30 something. Well, it's Apipa, it's not even, I didn't configure it at all. All right, so let's go back and configure this thing on static. All right. Oh, yeah, because I changed the switch, I guess. Yeah. So this is why, you see, when I disconnected, it lost the 30 and everything and put it back on Ryu, and he took the dynamic one, I guess. This is why. 001, and the default gateway will be 40.0.0.100, and the DNS will be 172.24.101. All right, let's try to ping the server. Ping 172.24.100.1. There you go. Right. So now my static routes are working very well, and you see that even my DNS can see the client here. I can ping the client. Not you. Here. So ping 40.0.0.1. There you go. Okay. So I can ping. Tell here I didn't do any DHCP or something. Why I did open this? No. So tell here I didn't do any DHCP yet, but I have my static routes working, and I can ping from this to this. So the ping is successful from the PDC to the client, and from the client to the PDC over these two routers. Okay. Let's take a little break. If you have any question, please ask your question. Otherwise, let's take a little break of 30 minutes, and we're going to come back and continue the configuration. Please let me know if you have any question. Is there any question? We're good? All right. Break time officially. Keep your phones next to you. I will notify you in 30 minutes.